For nearly 1,000 years, warriors clashed with shields, spears, and chariots that looked almost unchanged, despite endless battles and rising empires. In an age famed for invention, why did the real tools of war remain so stubbornly the same? The answer lies deeper than genius or bravery, in the hidden limits of bronze, the fragile lifelines of distant tin mines, and the tight grip of palace elites who controlled every blade. Before iron shattered the deadlock and redrew the map of power, the fate of armies and entire civilizations was balanced on the edge of metal few could truly command. This is the unseen struggle that shaped the ancient battlefield. Bronze was never just a metal. It was a delicate equation, balanced on the edge of chemistry and geography. To make a single sword or spearhead, ancient smiths needed copper, which was common across the Mediterranean, and tin, which was not. The recipe was unforgiving, more than 12% tin, and the blade would shatter in battle. Too little tin and it bent or dulled after a single clash. The ideal alloy, about 10% tin to 90% copper, demanded precision and experience, knowledge guarded by generations of palace smiths who worked behind closed doors. But the real challenge lay far beyond the forge. Tin was the rarest ingredient in the ancient world's arsenal. Copper could be mined in Cyprus, Anatolia, or Sardinia, but tin had to be hauled from the ends of the earth, out of the mines of Cornwall in Britain, the Erzgebirge Mountains in Central Europe, or the distant valleys of Central Asia. Every ingot crossed deserts, rivers, and hostile borders, changing hands dozens of times before reaching the workshops of Mycenae, Hattusa, or Thebes. Archaeological finds like the Uluburun shipwreck, dated to around 1300 BCE, lay bare the scale and fragility of this trade. Its cargo included nearly 100 tons of copper and 10 tons of tin, enough to arm thousands. Yet a single storm or ambush at sea could erase an entire season's supply. The copper-to-tin ratio in the hold matches the exacting standards of the smiths, proof that even at the height of Bronze Age power, the system ran close to the edge. Each weapon was the end product of a supply chain stretching over 3,000 kilometers. Lose a single link, a mountain pass blocked by snow, a port sacked by raiders, a caravan lost to drought, and the flow of tin stopped. Armories emptied, and the cost of outfitting a single soldier soared. States grew nervous, and palace economies strained to keep up with demand. In this world, the limits of warfare were set not by the ambitions of kings or the skill of generals, but by the chemistry of an alloy and the reach of a trade network that could vanish overnight. Power in the late Bronze Age rested in the hands of a few, kings, palace officials, and warrior nobles who controlled not only the land, but the very metal that made war possible. Bronze was rationed with bureaucratic precision. In the archives of Hattusa and Ugarit, clay tablets spell out the system, lines of cuneiform recording how many ingots each regiment received, which smiths could access the royal stores, and which units were due for new spearheads or chariot fittings. Every weapon issued was the result of a decision made by someone at the top, and every deviation from the standard came with risk. Palace economies ran like vast machines, but their gears were slow to turn. The cost of a single chariot, with its bronze-clad wheels and fittings, could equal the yearly income of a small village. Maintaining a chariot corps meant not only feeding and training horses and drivers, but dedicating teams of smiths to the constant repair and replacement of bronze parts. The chariot itself became a symbol of elite status, a weapon and a throne on wheels, reserved for the nobility and their chosen warriors. The more exclusive the access to bronze, the more tightly the ruling class clung to its privileges. Knowledge inside palace walls was guarded as fiercely as the metal itself. Smiths passed their secrets from father to son, forming tight-knit guilds that answered to the palace and the gods. Experimental alloys or new weapon shapes rarely left the shadows of the workshop. The risk of failure was too high, and the penalty for wasting precious tin could be severe. Innovation was discouraged, not because the smiths lacked skill, but because the system rewarded reliability and punished risk. Conservatism reached the battlefield. Armies across the Mediterranean and the Near East marched with the same types of spears and swords for generations. The spear, above all, was a weapon of the many, a simple, effective tool that could be cast in bulk, repaired with little metal, and wielded by both noble and commoner. Even as small changes crept in, slightly longer blades and new chariot models, the fundamentals remained untouched. The incentive was to hoard, not to experiment. When the great trading cities began to fall around 1200 BCE, the system's weaknesses were exposed. Ration lists grew shorter, procurement tablets recorded shortages, and the cost of equipping a single soldier soared. Bronze weapons were recycled, melted down, and reforged, sometimes with less and less tin. The palace's grip tightened, but the supply lines had already frayed. As collapse spread from Anatolia to the Levant, the old order found itself unable to adapt, locked in habits that had once ensured stability, but now left armies unprepared for a world where bronze could no longer be guaranteed. Iron was never a secret to ancient smiths. But for centuries, the metal arrived in small, unremarkable lumps, slag-filled blooms, stubborn to shape and weaker than the best bronze. Early bloomeries, little more than clay-lined pits fed by charcoal and hand-pumped bellows, struggled to reach the heat needed to transform ore into something useful. Temperatures hovered near 1,000 degrees Celsius, barely enough to coax iron from the rock, and never enough to melt it clean. Each bloom emerged riddled with impurities, its microstructure unpredictable, its edges soft or brittle. For a long time, iron was a curiosity, not a weapon of war. Then came the breakthrough. Across Anatolia and the Levant, anonymous smelters began to push their furnaces harder. Double-acting bellows, working in tandem, forced a steady blast of air through ceramic tuyères, narrow pipes that kept the heat focused at the heart of the fire. Furnace temperatures soared past 1,200 degrees Celsius, hot enough to drive off more slag and create larger, denser blooms. Taller, shaft-style furnaces appeared, their vertical chambers holding heat and charcoal for hours at a time. Instead of a handful of iron, these furnaces could produce enough metal for multiple blades in a single firing. Somewhere in this process, smiths noticed that reheating blooms in a carbon-rich fire changed the metal itself. Carburization, carbon atoms slipping into the iron, gave rise to a tougher, more flexible steel. The microstructure shifted, visible now in the fine grain of a well-forged sword. For the first time, iron could match or even surpass bronze for strength and edge. What began as scattered experiments quietly unlocked the possibility of mass production, setting the stage for armies to be equipped on a scale the old bronze system could never sustain. Iron's arrival on the battlefield was not a matter of sharper blades. It was a revolution in scale. For the first time, the metal that armed a soldier was drawn from local earth, not distant mountains or guarded caravans. The price of an iron sword fell to just 60 or 70% of its bronze predecessor, and the effect rippled outward. Where bronze had rationed power to the few, iron allowed states to equip the many. Armies swelled from a handful of elite charioteers to tens of thousands of foot soldiers, each holding a weapon forged from ore dug within a day's march of their village. The Neo-Assyrian Empire became the proof. By the 9th century BCE, Assyrian kings could field armies of 50,000 or more. Royal annals list entire divisions of iron-armed infantry, supported by logistical systems that dwarfed anything seen in the Bronze Age. Grain rations, water skins, and iron spearheads moved in columns stretching for miles. The numbers are staggering. A single campaign might see 12 tons of barley issued per day, while state forges turned out thousands of new weapons each season. Iron's abundance meant that when a spear broke in the field, it could be replaced by the local smith, not shipped from a distant palace foundry. The battlefield itself changed. Massed infantry formations, phalanxes, and shield walls became possible only when every man could be armed at reasonable cost. Iron tools improved roads and siege works, supporting armies on the move for months at a time. The old world of rationed metal and elite privilege gave way to a new order, where the scale of war was limited less by scarcity and more by the will and organization of the state. The spread of iron was not just a technical shift, but a transformation in what an army could be. Today, technological leaps still hinge on resources, institutions, and timing, not just bright ideas. As global supply chains and power structures define what is possible, history reminds us, true transformation demands more than invention. The world advances only when the system itself is ready to change. Thanks for watching.